Yes, dear students, continuation of the previous topic, thermodynamics. So previously we have discussed various parameters like what is meant by heat, how heat energy will be defined, that is it is a disordered form of energy, so that is due to the temperature difference, that is called heat energy, right? So then also work will be discussed, so that is the ordered form of energy, so hence it is due to other than the temperature difference, that will be discussed. After that some two parameters, internal energy and enthalpy also discussed, right? So then also state functions and path functions also discussed, right? So then now coming to the part, right? So we said that thermodynamic process. What is meant by thermodynamic process means the temperature, pressure, right, volume, any one of the property becomes changes, right? So that is with respect to time. As the time is going on, one of the property can be changes, therefore that will be involved in thermodynamic process. If there is no change of property with respect to time, that is called thermodynamic state, right? So that already discussed, right? So then go with thermodynamic process. Right. Thermodynamic process. So thermodynamic state properties will be like any system we may consider, that is the system is present at T, temperature, pressure is V and volume is V. These are the state properties or thermodynamic state variables, right? So those variables, one of the variable will be change, means other variables may be same, right? So depending on that, so we are going to getting the various thermodynamic processes, right? So simply think, so here we are going to discuss, right, by considering of system A. System A is converted to system B. System A is converted to system B. We are not describing about pathways, just one system is converted to the other system, right? During this conversion, right, temperature will be T1, pressure will be P1, volume is V1. So these parameters are going to change, but temperature is T1, pressure is P2, volume is V2. Which property will be same? Temperature is remains same throughout conversion of system A to system B, right? So means here, right, here temperature will be constant only, right? During this conversion temperature is constant, means hence such process is called as temperature is constant, means such process is called as isothermal process. With respect to the constant, right, the other pressure will be changes and volume will be changes, but which one is constant? Temperature is remains constant, hence such process is known as what? Isothermal process. Means this is the one of the thermodynamic process. That thermodynamic process will be expressed with the help of constant parameter, right? So ఏమన్నా మనం సిస్టమ్ సరౌండింగ్స్ మధ్య ఏదైనా ప్రాసెస్ జరగని, హీట్ ఎనర్జీ గివెన్ టు ద సిస్టమ్ ఆర్ ఫ్రమ్ సరౌండింగ్స్ టు సిస్టమ్, ఏదైనా ప్రాసెస్ జరిగితే ఆ ప్రాసెస్ సమయంలో ఏ ప్రాపర్టీ అనేది కాన్స్టాంట్ అయితే ఉంటుందో దాన్ని బేస్ చేసుకొని మనం థర్మోడైనమిక్ ప్రాసెస్ని డిఫైన్ చేస్తాం, రైట్? సో దెర్ ఆర్ 5 థర్మోడైనమిక్ ప్రాసెసెస్ ఆర్ దేర్, రైట్? So the first one will be isothermal process. Right? So what is meant by isothermal process means for the conversion of system A to system B, throughout this conversion temperature remains constant. Whenever temperature remains constant, the change of temperature dt will be equals to 0, or we may written as delta T will be equals to 0. These are the conditions which are applicable for isothermal process, right? So means this is the process we are going to express, the temperature will be constant, means such process becomes what? Isothermal process. When temperature is constant, already we said that system temperature and surrounding temperature will be same, hence system is equilibrium with surroundings, System is equilibrium with surroundings, right? So how that equilibrium condition, with the help of that, how we are going to express the various thermodynamic class, that we will see, right? So once temperature is constant, this is the diagram is applicable for only this isothermal process, right? Like that, temperature will be changes but pressure will be constant. In next case, temperature will be changes, pressure will be constant, right? So that is the process is what? Isobaric process. Isobaric process. For isobaric process, what? Pressure is remains constant, right? So then change of pressure dP is equals 0 or delta P is equals to 0. How we are going to say? The system A is converted to the system B. Throughout this conversion, pressure will be same. Throughout this conversion, pressure will be same. Once temperature will be constant, that is the isothermal process. In temperature T is there, therefore T is constant, right? So when T is constant, the change of temperature means, if you may consider the change of temperature, this T1 minus T1, both temperatures are same, therefore T1 minus T1, that becomes 0. The change of temperature becomes 0. This D will be small change, delta will be large change. Whenever we may use D, so that will be used for small change. Delta will be used for large changes. Any large change will be there. Large changes, right? So that I am going to explain how it will be small changes and large changes, right? So here only we'll see for isothermal process how it will be large changes and small changes, right? So this is the system A. This is the system A is present at 25 degrees centigrade. The system A is present at 25 degrees centigrade. The system A is converted to system B. System B. System B also present at 25 degrees centigrade. Same temperature means that is the process is called isothermal process. Isothermal process. Whether it will be happened in a single step or in several steps means, right? If it is happened in a several step, at any step the temperature will be same only. Here 25 degrees centigrade, here 25, here 25. Like this, the system A is converted to the system B. If you may consider this is the difference, whatever the difference here we may consider, that we may have written as dt. Dt means that is a small change. So the large change means from A to B, if we may consider this is the large change, that we may have written as delta T. This is the difference of small change and large change that will be considered in our thermodynamics, right? So coming to the part of third one, temperature is once constant, right? So temperature is once constant, that is the isothermal process. Then next pressure is constant, that is isobaric process. Then after temperature and pressure, what about one more? That is the volume is constant. Therefore isochoric process. Isochoric process. For isochoric process, which one is constant? Volume is constant, right? So for isochoric process, volume is constant. When volume is constant, what we have to written? So dV is equals to 0 or delta V is equals to 0. These are the conditions, right? If we may represent in this manner, the system A is converted to system B. Throughout this conversion, volume will be kept constant. So here V1, there V1. The other parameters may be changed, but only volume is kept constant. Hence that process is becomes what? Isochoric process, right? So whenever volume is kept constant, this is the process is isochoric process. Pressure is constant, that is isobaric process. The first one is what? Isothermal process. In addition to this, another two processes will be there, right? So that are adiabatic process and cyclic process, right? So the fourth one will be adiabatic process. Adiabatic process. All the three parameters, temperature, pressure and volume will be over there, right? So for adiabatic process, right, Q is remains constant. Q means heat energy. Heat is remains constant. Whenever Q is constant, we have to written as dq is equals to 0 or delta Q is equals to 0. These are the conditions which are applicable for adiabatic process. So how we will represent this adiabatic process, right? So there is a system A is converted to system B, but throughout this heat will be constant. There is no exchange of heat. There is no exchange of heat, or there is no change of heat energy during that conversion of system A to system B. Hence, that is the process is known as what? Adiabatic process. Adiabatic process, right? ABP, right? So then last one is the fifth process will be there. That is the what? Cyclic process. So that is the cyclic process. What is meant by cyclic process means any process that is carried out in a cyclic manner. That means system A is converted to system B, then system B is converted to system C, system C is converted to system D, again D is converted to system A. There are 4 processes are there. All the 4 processes are carried out in a cyclic manner. That is A to B, B to C, C to D and D to A. Means initial states and final states are same. Initial states means whatever the states it has at the system A, even final also same states will be there. When initial and final states will be there, right, the change of thermodynamic properties, that is delta E, delta H, delta G, then delta S, then delta A, this all will be equals to 0. This is applicable for cyclic process. Whatever is the process which will be carried out in a cyclic manner, how we have to remember all the thermodynamic processes means when the process is involved, I said that, right? So one of the parameter will be changes with time. Whenever one parameter will be changes, other parameters will be kept constant. Based on that constant terminology, we are going to express the thermodynamic process. Right? 5 parameters we have to remember. Based on that 5, we will get 5 thermodynamic processes. One will be if temperature is remains constant, that is called isothermal process, ITP. Right? Pressure is kept constant, that is isobaric process. That is isobaric process. Volume is kept constant, that is isochoric process. Then adiabatic process means Q is kept constant. Then for cyclic process, all the thermodynamic change of thermodynamic properties becomes 0 because initial and final states are same. Initial states is equals to final states. Whenever initial and final states will be same, that is the process is carried out in cyclic manner, right? So once the process is becomes cyclic manner, the change of all the thermodynamic properties becomes 0, right? So these are the thermodynamic processes. In detail we have to discuss about all these thermodynamic processes, right? So just briefly about what is isothermal, what is isobaric, what is isochoric, what is adiabatic, what is cyclic process. 5 processes will be there. Each process will be discussed in detail. Actually just simply mentioned in our syllabus, that is the various processes in reversible and irreversible processes only mentioned. But as we know that isothermal, what is meant by isothermal, isobaric, isochoric, adiabatic and cyclic process, in all the cases we are going to get work done, and also which will be applicable for reversible and irreversible phenomenon also. What is meant by reversible and irreversible, that we will see, right? Okay, then so we'll explain in detail about thermodynamic process. The first one is isothermal process. Isothermal process. What is meant by isothermal process? Just now we discussed that temperature is remains constant. When temperature is remains constant, delta T or dt is equals to 0. right? So yesterday we discussed that internal energy is as function of temperature. So therefore hence dt is equals to 0 means internal energy also equals to 0. The change of internal energy will be equals to 0 because internal energy is as function of temperature, right? How it will be equals to 0? So that even we will get even further classes, right? So this is the isothermal process, right? In isothermal process some expansion and compression will be taking place, right? Expansion and compression will be taking place. When expansion process will be taking place, when compression process means, first we have to know about the expansion and compression process, right? So what is meant by expansion, what is meant by compression, right? So if with the help of that we able to know what is meant by isothermal expansion and what is meant by isothermal compression, then we are going to work done calculation for isothermal expansion process and compression process, right? So simply think, right, if you may consider a cylinder with a weightless frictionless piston, right? This is the what? Piston. This is the weightless frictionless piston. The cylinder is consisting gas, therefore pressure of the gas is this one. Then outside pressure will be, some gases will be there. This is the outside pressure direction and inside pressure direction will be this, right? Initially volume will be V1, volume of the gas is V1. When the pressure of the gas is much greater than P external, right, inside pressure will be more, means that piston will be simply moves up, right? Means the volume of the gas is increases. Hence volume of the gas is increases, the process becomes what? Expansion process. For expansion process the obtained work is negative. Why negative? Means work done by the system will be taking place. Yesterday we discussed that work done by the system means the system is going to lose some amount of energy, so therefore W is equals to negative. This is the expansion process, right? Right. Next one will be compression process will be there. Same cylinder containing gas, right? So the pressure of the gas will be P of G and external pressure is P external, and this is the piston, weightless frictionless piston. So I said boundary surface is there. That boundary surface may be imaginary here. We have to imagine a piston or that weightless frictionless piston we have to keep, right? So with the help of that, here what is the condition we have to apply? What about previous condition? Pressure of the gas is very high. Now external pressure is very high. External pressure is very high compared to pressure of the gas. With the help of this, the gas volume of the gas will be decreases, right? Hence this is the V1 to V2 means that process becomes compression process. During compression process work is done on the system, therefore W is equals to positive, right? So this again I will explain at the time of what? Reversible and irreversible, right? Here we are going to discuss the process for isothermal process whenever expansion and compression will be there, right? See, for isothermal expansion process. For expansion some energy is required, right? So whatever is the process is undergo expansion means some energy is required. That energy, two possibilities are there. As we discussed that every system has some stored energy, or else the sum of all the kind of energies are present in the system is called internal energy. Either the system can utilize this internal energy for expansion, or that should be taken from the surroundings. Two possibilities are there. Which possibility is correct for expansion process, we'll see. Right. So here one will be, it is taken from its internal energy. The energy which can be utilized to do expansion process in isothermal process, the energy which is taken by internal energy. Once internal energy will be utilized, therefore internal energy is decreases. So as internal energy is decreases, the temperature also decreases. But what is the isothermal process? For isothermal process temperature is constant. So but here what we are getting, temperature is decreases, means this is the procedure is not follows. Whatever the expansion process was done in isothermal means at constant temperature, therefore that required energy will be taken from surroundings only, right? This is the process should be possible. Two possibilities, not only in isothermal, in all the cases two possibilities are there. For expansion, either energy will be taken from the internal energy or taken from the surroundings. Which one is suitable for that, right? If internal energy can utilizes for expansion, internal energy will be decreases. As internal energy is decreases, temperature also decreases. As I told, internal energy is as function of temperature, therefore temperature also decreases. But temperature decreases is not possible for isothermal because temperature is always constant, hence this is the procedure we cannot follow. Then the other will be what? So which is taken from the surroundings, right? So whenever some amount of energy is taken from the surroundings, right, so then the process of expansion will be taking place at a constant temperature. That you have to understand. Similarly for compression process, also we will go compression process, right? Whenever we may consider, if the whatever is the energy is there, that will be stored in the form of internal energy, means system is gaining here. System is gaining means any energy that will be stored in the internal energy, means internal energy is increases. As internal energy is increases, temperature also increases, therefore that procedure not follows. Whatever is the energy is there, that will be stored in the surroundings, right? So here energy will be taken from the surroundings. For compression process, energy will be stored in the surroundings. So that is the phenomenon that will be follows in isothermal process, right? This we have to understand how the temperature will be constant during the temperature. If any expansion and compression process should be done, so the energy is required. That required energy will be utilized by either its internal energy or that will be from the surroundings, right? The energy taken from the surroundings, expansion process will take place. The energy is given to the surroundings, compression process will be takes place. During that both the processes, temperature remains constant, hence that is the process is known as isothermal expansion process. Isothermal expansion process. Similarly for compression also, instead of this taken, what we have to write? Stored to surroundings, here stored in the form of internal energy, right? If you may consider compression process, because this expansion and compression will discuss again after reversible and irreversible process also, right? So this is the scenario will be applicable for all the processes, right? Like isothermal process, isobaric process and isochoric process, right? Isothermal, isobaric, isochoric and as well as adiabatic and cyclic process, right? Whenever temperature is constant, just we are going to explain about some of the gaseous laws. Which law is applicable for constant temperature? For constant temperature, at constant temperature, Boyle's law is applicable. Somehow gaseous laws and states of matter, all those things will be covered here, right? So just remember why we started thermodynamics. Means whatever we may consider the reactions are chemistry oriented, at any chapter thermodynamics concepts will be included, right? So because you are going to express any one reaction is there, right? That reaction heat will be liberated or heat is observed, means that is related to thermodynamics only, right? So the ideal gas, ideal solutions, all those concepts, mixing process, right, that will be continuously taking place or not, all those things will be explained with the help of thermodynamics, right? Boyle's law is applicable, right? So what is meant by Boyle's law? At constant temperature, pressure is inversely proportional to the volume. The pressure of the gas is inversely proportional to the volume, right? So this is also we may have written as P is equals to some K into 1 by V, therefore PV is equals to K, where K is what? Constant, right? So where K is a constant. Right, if we made different pressures, different volumes we will get, hence P1 V1 is equals to P2 V2, because these both are equals to same constant only. So hence we may have written as P1 by P2 is equals to V1 by V2 by V1, V2 by V1. These all formulas are helpful to get the information in case of isothermal process. Boyle's law is applicable, therefore these are the conditions we are getting, then we can get the plot of Boyle's law, right? Why particularly we are going to discuss about PV means pressure volume work. Yesterday we discussed that whenever PV is there, that is nothing but pressure volume work only, right? So therefore pressure volume work means, right? So therefore with the help of these, what we have to write, P is equals to K into 1 by V, or P is equals to KV. As pressure is increases, right, volume is decreases, or pressure is decreases, volume is increases, right? Hence we will get like this. As the pressure is decreases, we will get like this. So this is the curve is known as what? Hyperbola. So what is this curve? That is hyperbola. Right, hyperbola curve will get. As pressure is decreases, volume is increasing, because pressure is inversely proportional to the volume at a constant temperature, right? So or else one more plot also we have to write, right? So that will be directly 1 by V versus pressure. What we are taking here? 1 by V values. Volume is decreases, but 1 by V values we are considering, therefore hence passing through origin will come. The line which is come from passing through origin, right? So this is the concept is isothermal. For expansion and compression, energy will be utilized by the surroundings only, not in internal energy, and at constant temperature Boyle's law is applicable, therefore so these are the plots we'll get, and another one more two plots also applicable, that we'll see, right? Means PV versus V, next PV versus P, right? So means PV is the product, right? So that is the PV versus V. Next one, next graph will be PV versus P, PV versus P, right? What type of graphs will expect, right? So here PV is what? PV is always constant. If you can change the pressure or if you can change the volume, right? So there is no change of that PV value. PV is always constant only. PV, the product of pressure and volume is always constant at a constant temperature. At constant temperature. So that becomes what? Constant only. If you can change the volume, there is no change of PV product. If you can change the pressure, there is no change of PV product, because PV is always constant at a constant temperature. That is the Boyle's law. These are the four kind of graphs are applicable, and Boyle's law is applicable for isothermal process. Isothermal process, right? So similarly various gases laws are applicable here, right? So that are for remaining others that we will see, right? So next, after isothermal process, what we are going to discuss? Isobaric process, right? So the second one will be what? Isobaric process. Isobaric process, right? సో ఎవరైనా ఏదన్నా అంటే అప్పుడే మనకి ఏం రేజ్ అవుతుంది? బీపీ రేజ్ అవుతుంది, రైట్? సో ప్రతి చిన్న విషయానికి ఇమీడియట్గా బీపీ రేజ్ అయిపోతుంటుంది, రైట్? సో వాట్ ఈజ్ మీన్డ్ బై దట్ బీపీ మీన్స్ బారిక్ ప్రాసెస్ మీన్స్ ప్రెజర్ ఈజ్ కాన్స్టాంట్. For boric process, pressure is constant. You have to remember like that. Don't get confusion. So you have to remember BP, right? So boric process means pressure remains constant, right? So that pressure remains constant. pressure remains constant. Therefore change of pressure will be dP is 0 or delta P is 0. What is meant by dP? Small change of pressure. Delta P means large change of pressure. Both will be, change will be equals to 0 because pressure is always constant. That is the word isobaric process, right? So for isobaric process, right? So even during this isobaric process, right? So one system is converted to the other system, right? One system is converted to the other system. Throughout that conversion, pressure is remains constant. Whenever pressure is constant, so the other properties may be vary. If we can change the volume, right, with respect to constant pressure, therefore there is a work done will be there, right? So what is meant by work done in isobaric process, and how that expansion and compression process will be takes place means that is the similar to that only, right? So then here, whenever pressure is constant, which law is applicable? Charles' law is applicable. Charles' law is applicable. What is meant by Charles' law? At constant pressure, right? So volume is directly proportional to temperature. At constant pressure, volume is directly proportional to temperature, right? So if you can remove proportionality with some constant, that is V is equals to K by T or V by T is equals to K, this is the equation. From this, what we are going to write means V1 by T1 is equals to V2 by T2. V1 by T1 is equals to V2 by T2, or else V2 by V1 is equals to T2 by T1 we have to write. Volume is directly proportional to temperature. Charles' law is applicable at constant pressure. Volume is directly proportional to temperature, right? So these are the equations will be applicable. Then coming to the part of Platt's, right? When V is directly proportional to T means V is equals to KT, right? So therefore V is equals to KT we have to utilize, right? So that is the what we are getting, right? So that is the what we are getting here on y-axis volume, here temperature. Therefore we will get the line which is passing through the origin only, right? So if you may consider the slope, that slope will be equals to constant only, right? Next, one more two graphs are there, that is V by T versus V, then V by T versus T, right? V by T versus V means V by T is always what? Constant only. Therefore that does not change with volume. If volume will be changes, what about that ratio of V by T? That is always constant only, right? So as we discussed that product is always constant at a constant parameter. Here constant parameter is pressure is constant. At constant pressure, if you can change the volume, this product means this is the ratio of volume by temperature is remains constant only, right? Coming to the part of here, right, as temperature is there, so therefore volume by T, so that remains what? Constant only, right? In addition to these three Platts, one more Platts also we will get, right? One more Platt we will get. So what is meant by that one more Platt means applying of logarithm, right? So V is equals to what? K into T. By applying of logarithm, log V is equals to log K plus log T. Log A into B formula, directly I am going to write log K plus log T. This is in the form of Y is equals to C plus M into X, where M is equals to 1 only. So hence we will get one more Platt by taking off logarithmic values, right? So what is meant by on y-axis? Log V. So on x-axis log T, right? So therefore that will give with some positive intercept. If you may consider here slope, that slope will be equals to 1. This is the intercept is equals to log K, right? These are the four kind of Platts which are applicable. I already mentioned in the class, right? ఇవన్నీ ఏం లేదండి, జస్ట్ ఈక్వేషన్ వస్తే కాన్సెప్ట్ తెలిస్తే తరోగా ఇవన్నీ ఈజీగా రాసుకుంటూ వెళ్ళిపోవచ్చు, రైట్? ఒకదాని నుంచి ఒకటి లింకే, కొత్తగా ఏం లేదు. జస్ట్ ప్రెజర్ ఐసోబారిక్ అనగానే ఇవన్నీ విచ్ ఆఫ్ ద ఫాలోయింగ్ ప్లాట్ ఈజ్ అప్లికేబుల్ ఫర్ ఐసోబారిక్ ప్రాసెస్ అని అంటాడు. Which of the following plot is, 4 plots will be given, right? Which of the following plot is applicable for isobaric process? Like this will be given, this will be given, and this will be given. Even some other will be given like P and PV, that will be straight line. So simply we have to identify the plot, right? Definitely 1 or 2 questions will be there with graphical phenomenon in the examination. Even you may consider in the previous examination, అంతకుముందు ఎగ్జామినేషన్ ఎక్కడ తీసుకున్నా కంపల్సరీ గ్రాఫ్స్ రిప్రజెంటేషన్ మీద ఐదర్ ఇవైనా కావచ్చు, లేదా సైక్లిక్ ప్రాసెస్ గ్రాఫ్స్ అయినా కావచ్చు, లేదా రివర్సిబుల్ ఇర్రివర్సిబుల్ గ్రాఫ్స్ అయినా కావచ్చు. సో గ్రాఫ్స్ ఆర్ వెరీ ఇంపార్టెంట్. విత్ ద హెల్ప్ ఆఫ్ గ్రాఫికల్ ఫినామినన్ వీఆర్ గెట్టింగ్ హ్యూజ్ ఇన్ఫర్మేషన్ రిగార్డింగ్ దీస్ వేరియస్ ప్రాసెసెస్, రైట్? వేర్ వీ హ్యావ్ డిస్కస్డ్ 4 plots and here we have discussed 4 plots, right? Then one more will be there, that is isochoric process, right? There also we will get like that information, right? So that is isochoric process. So means student, just isothermal, isobaric, adiabatic, just a fraction of time we can say easy ga cheppochu. Isothermal ante temperature constant, change of temperature 0 అయిపోయింది అది. Isobaric ante ప్రెజర్ కాన్స్టెంట్, చేంజ్ ఆఫ్ ప్రెజర్ 0. విచ్ లా అప్లికేబుల్? చోరస్లో అప్లికేబుల్. అయిపోయింది. సో అట్లా ఈజీగా కంప్లీట్ చేసేయచ్చు. వీఆర్ గివింగ్ డెప్త్ సబ్జెక్ట్ మీన్స్ వెనెవర్ the examiner think that will enter into in-depth level, so even such points will be covered, right? So then coming to the part of isochoric process, right? Isochoric process, right? What is meant by isochoric process? Pressure is completed, temperature is completed, therefore remaining volume is there. Therefore we have to remember, right, the one of the famous scientists, that is C.V. Raman, who invented Raman effect, got Nobel Prize for that, right? So C.V. Raman, sir, C.V. Raman you have to remember. So C.V. is there means choric process means volume is kept constant, right? Don't forget, right? So for isochoric process, volume is kept constant. Volume is kept constant means the change of volume is becomes 0, that is dP is equals to 0. Here we have to get one equation, that is the work done is equals to P into dV. If it is P is external minus P with external into dV, so therefore this is minus P into dV means V2 minus V1, V2 minus V1. Both the volumes are same because volume is kept constant means therefore the obtained work is 0. For isochoric process, what about the work? That work will be always 0 only, right? Sir, what about the work done in other processes? As we will discuss, even all the processes, work done calculations are there, equations are there. Definitely we will discuss all those things. Right here dV is there, so directly we are able to get work done W is equals to 0, right? Right. When volume is constant, which law is applicable? Boyle's law is over, Charles' law is over, then which law? Gay-Lussac law is applicable, right? Gay-Lussac law is applicable. What is meant by Gay-Lussac law? What is meant by Gay-Lussac law? At constant volume, right? At constant volume, right? Pressure is directly proportional to temperature. At constant volume, pressure is directly proportional to temperature only, right? So therefore P is equals to K into T, therefore P by T is equals to K, where K is constant. Where K is what? Constant, right? Similarly from this, what we will get the equations? P1 by T1 is equals to P2 by T2, or this we may have written as, right, P2 by P1 is equals to T2 by T1. These all the equations are helpful whenever we are doing numericals based on the work done concept, right? At that time these all relations are helpful. Each and every relation is important. If volumes are given, which equation is utilizes to do calculation of work done? If pressures are given, how we have to convert it into volumes, right? So if temperatures are given, converted into pressures, all those conversions are very important, right? Okay. So then similar to this, we are going to discuss about the plats, right? We are going to discuss about the plats, right? We'll see. What are the plats which are applicable for Gay-Lussac law, right? So pressure versus volume, pressure versus temperature, right? P is directly proportional to T means, so that we will get directly passing through origin. So this is the y-axis pressure and x-axis temperature, right? On y-axis pressure, x-axis temperature, right? So another two plots will be there, right? So that will be P by T versus pressure. So here P by T, then we have to take pressure. P by T is always constant with respect to that. Therefore, this will be constant only, right? So one more graph we will get, right? So here we use it to express, that is P by T versus T. P by T is always constant, therefore we will get like this. Then similar to the previous one, logarithm, right? So what we will write? Log P versus log T plot. Log P versus log T. At constant volume, P is directly proportional to temperature. So therefore we have to write, right? So directly we have to take that equation and apply logarithm, and based on that we have to apply the concept. Therefore log P versus log T, here also we will get like this. This intercept will be equals to log K, then slope will be equals to 1 only, right? Slope will be equals to 1, right? These are the four plots which are applicable for isochoric process. But in addition to this, here we have to get one concept, right? Isobars, isotherms and isocores, right? What are meant by isobars, what are meant by isotherms, what are meant by isocores, right? That we will discuss, right? Isotherms means, so which will be related to all these three, right? So we are going to discuss these plots which will be related to all these things. These are very, very important. Based on this only questions will be there. Even one previous question also will be there based on this, right? So even NEET examination will be there. So there is a one question regarding this isotherms, isobars and isocores, right? So all will be here only we'll discuss. Isotherms, right? Next one isobars, right? Next one isocores, right? So what are the plots we have to know first, right? For isotherms, right? So for isotherms, what we will get, right? So which follows Boyle's law. Boyle's law, pressure is inversely proportional to volume at constant temperature. This already we know, right? So we are going to plot the graphs, right? So this is what pressure and this is the volume. How many kind of plots we are getting, right? So this is the what? One curve, right? At one temperature, this is at another temperature, and this is at next temperature. Three different temperatures are there, therefore we got three different lines, right? So the temperatures will be, right? So this is the T1, this is the T2, this is the T3, right? Or we may consider like, so this is the what? T1, this is the T2, this is the T3, right? So three different kind of temperatures are there, therefore we will get three hyperbola curves, right? So how we are getting the relation between them? Means T3 will be more or T1 will be more? We are getting three lines. First we draw three lines only. Which temperature will be more? Means this first line temperature will be more or the last line temperature will be more? What is the relation between these temperatures? That can be explained isotherms concept, right? So what is meant by that, right? Here just we have to keep pressure is constant. Pressure is constant, right? So this is the volume, this is the corresponding volume is what? V3, right? This is the corresponding volume is V1. This is the corresponding volume is, sorry, V1, this is the V2, right? So this corresponding volume is V2, right? See, so with the help of this picture, V1 is more or V3 is more? The volume is increasing on x-axis, right? At constant pressure, right? So V3 is greater than, V2 is greater than V1. But at constant pressure means Charles law is applicable, right? At constant pressure, which law? Charles law. What is meant by Charles law? At constant pressure, volume is directly proportional to T. Hence, T3 will be more than T2 will be more than T1. This is the relation we will get, right? This is the T3 is the higher temperature, T2 is the lower temperature, T1 is the lower temperature. This is the temperature relationships between isotherms, right? So then similarly go with isobars, right? Isobars means at constant pressure, volume is directly proportional to temperature. So volume versus temperature we have to consider, right? Volume versus temperature. What about the plots of volume versus temperature, right? So this is the volume and this is the temperature. We will get 3 straight lines, means at a different pressure we will get like this. This is the pressure 1, pressure 2, then pressure 3. What are the relationships between these pressures? Now we are going to find out with the help of similar to this. As you understand this one, therefore we will get easily this is, right? So such type of questions, this type of questions, by giving these plots and which of the following relation is correct. So T2 is greater than T2, T3 is greater than, T2 is greater than T1, or else one more will be reverse, or else all are equal. Such type of options we will get, right? Then here P1, P2, P3 will be given, right? Now what we have to kept constant? Volume is kept constant. Here we have to kept constant volume. At constant volume, this is belongs to what? This is the P1 means, this is the temperature is belongs to T1, means similar terminology I am using, right? So then P2 means this is T2. Here P3 means this is T3, right? This is the 0. See, as the temperature is increasing on x-axis or not? As temperature is increasing means here T1 will be increasing, right? Means temperature T1 will be more, right? That we have to write at constant temperature, right? Sorry, at constant volume, right? Which one? T1 is greater than, T2 is greater than T3, means this T1 will be more temperature. The corresponding is what? P1, because at constant volume pressure is directly proportional to temperature only. Therefore hence P1 will be more, P2 will be more than P3. This is the higher temperature, this is the remaining two are the lower temperatures. Sorry, lower pressures. Higher pressure line, the remaining are lower pressure lines. Or if you may give, this is the P3, P1, P2. Such kind of relation we will get based on the plot only. Or else simply I am going to change here. This is the P1, this is the P3, right? So don't confuse this P1 and P3. P3 is there means, what about the corresponding relation? T3. So here what is? T1. Right? So therefore, what is the relation in this case? Right? So therefore, T1 will be, both are correct only. As I am changing, I am expressing. Depending means depends on the given data only we will get the answer. Right? So T3 will be more here. T3 will be more, then T2, then T1. So the corresponding P3 also will be more. Therefore P3 is greater than, P2 is greater than P1. So this is always higher pressure curve only. Previously also we got higher, that denoted with P1 only. Now denoted with P3. Means both I am expressing, right? So don't go with 1, 2, 3 number. So just go with concept, the corresponding relations we will get easily, right? If we consider P1, previously we got P1 will be more, right? So means this is the higher pressure only. So with the help of concept, right? Similar to ISO course, right? ISO course, what are meant by ISO course? At constant volume, pressure is directly proportional to temperature, right? These all are P1, P2, P3 are isocores. These are T1, T2, T3 are isotherms, right? So then isocores means V1, V2, V3 will get. So therefore the corresponding we will do, right? So this is the pressure and temperature, right? Pressure is directly proportional to temperature is there. Therefore we will get 3, right? 3 lines will get, right? This is the V1, this is the V2, this is the V3. V1, V2, V3, right? So therefore again same we have to apply the condition constant pressure, right? So this V3 will be corresponding relation is T3, V2 means corresponding is T2, V1 means corresponding is T1. V1 is corresponding is T1. So hence at constant pressure, what is the relation here? T3 will be more, right? T3 will be more, then T2 is more than T1, because on axis we know that the values are increasing, right? With respect that at constant pressure, what about the volume and temperature relation? Charles' law, that is volume is directly proportional to T. Therefore V3 is greater than V2 is greater than V1, right? So these are the relations we are getting like this, right? If you can change this V1 to V3, V1 to V3, this is V1, this is V3, that V1 will be more volume will get, right? So corresponding to the temperature. These are the curves. From based on that only we will get the questions of like isotherms, isobars and isocores. Most of the topic of gaseous state, gaseous laws all will be covered here. So once again we will discuss at the time of again gaseous laws. Then these relations will be applicable for the isothermal, isobaric and isochoric processes, right? So these are the relationships we are getting. Even we can get this is changes also. Temperature will be taken here, pressure will be taken here, like that. At constant temperature, isothermal. So therefore pressure will be inversely proportional to volume. All such kind of relations we will get, right? So whatever the given chart will be there, with the help of that chart we have to apply our concept. So then the corresponding result will get, right? So then coming to the part of adiabatic process, right? Adiabatic process. Even here also 1 by V we have to utilize. That is also straight lines we will get in isotherms also, right? Because P versus 1 by T will give straight lines only, right? Coming to the part of fourth process, that is adiabatic process. It is very important. Many applications are there. At Joule-Thomson experiments we can use this condition, that is adiabatic process. What is meant by adiabatic process? Q is always constant. When Q is always constant means dq will be equals to 0 or delta Q is equals to 0, right? So from first law of thermodynamics we will discuss, just remember this. dE is equals to means change in internal energy is equals to Q plus W, right? So that is delta Q plus W. Delta Q is 0 means delta E is equals to W, we will get the relation, right? As internal energy is increases, therefore that work also increases. That means work positive means work done on the system. Work done on the system at that time only W is negative, right? So for example, this we may consider as minus delta E. Minus delta E is equals to minus W, right? W is minus, means minus delta I means internal energy is decreases. When internal energy is decreases, the obtained work is negative. That means work done by the system will be taking place. Here work done on the system. Internal energy పెరుగుతుంది అంటే ఏమైనట్టు, వర్క్ డన్ ఆన్ ద సిస్టమ్. అంటే సిస్టమ్ అనేది గెయిన్ చేసుకుంటే ఇంటర్నల్ ఎనర్జీ అనేది ఏమవుతుంది, ఇంక్రీజ్ అవుతుంది. అదే సిస్టమే వర్క్ చేసింది అనుకో, ఇంటర్నల్ ఎనర్జీ ఏమవుతుంది, డిక్రీజ్. దేర్ఫోర్ వర్క్ డన్ బై ద సిస్టమ్. Very important terminology, right? So that are applicable in case of adiabatic process, right? So similarly, as we discussed that whenever the adiabatic process will be takes place, adiabatic process, so that is particularly expansion process we'll see. Expansion process, adiabatic expansion process. So to get expansion, remember that some amount of energy is required. Some energy is required. That energy will be taken from either internal energy or what, surroundings. Two possibilities are there, right? So one is from internal energy taken from internal energy, right? So here taken from surroundings, right? So whenever dq is 0, remember here this is also important. Whenever dq is 0, so this dt change in temperature is not equals to 0 or dt is not equals to 0. Means there is a temperature change is there when heat is not allowing from system to surroundings, right? It is not allowing from system to surroundings or surrounding to system. No transfer of heat is taking place, means at that time there is a temperature difference will get. So delta dt is not equal 0 means there is a temperature difference is there. So right, when will get temperature difference, right? So for expansion process some energy is required. That energy will be taken from the internal energy. Therefore when internal energy is utilized, internal energy is decreases. Hence internal energy is decreases. What is decreases? Temperature is decreases. Hence temperature is decreases. That will be cooled in this process. Whatever is the gas that will be expands, whatever is the gas that will be expandable in adiabatic condition, the gases will be cooled. That is the Joule-Thomson experiment. Whenever gases are involved in their expansion process, right? So the temperature of the gas should be decreases, particularly by maintaining adiabatic condition. Hence this is the process should be follows, but not this. For isothermal process, that will be taken from the surroundings, right? But for adiabatic process, what? So that should be taken from internal energy. That is the difference you have to identify. ఇంటర్నల్ ఎనర్జీని ఎవరు యూజ్ చేసుకుంటారు, అడియాబేటిక్ ప్రాసెస్లో మాత్రమే ఇంటర్నల్ ఎనర్జీ అనేది యూజ్ అవుతుంది. అదే ఐసోథర్మల్కి వస్తే ఐసోథర్మల్లో ఏ ఎనర్జీ, సరౌండింగ్స్ నుంచి ఎనర్జీ, రైట్? ఐదర్ సరౌండింగ్స్ కన్నా ఇవ్వడం లేదా సరౌండింగ్స్ నుంచి తీసుకోవడం. ఇంటర్నల్ ఎనర్జీ డిస్టర్బ్ అవ్వదు బికాజ్ కాన్స్టాంట్ టెంపరేచర్ ఇస్ దేర్. ఇంటర్నల్ ఎనర్జీ ఈజ్ ఏ ఫంక్షన్ ఆఫ్ టెంపరేచర్, రైట్? సో దట్స్ వై దిస్ ఈజ్ ద ప్రాసెస్ విచ్ వి మే అప్లికేబుల్. హెన్స్ దిస్ ఈజ్ ద సేమ్ కాన్సెప్ట్ ఆఫ్ అడియాబేటిక్ ప్రాసెస్ విల్ బి utilized in Joule-Thomson experiment also, right? So this is the conditions are applicable for adiabatic process and which process can be utilized like that. This is the terminology also most important. Whenever internal energy is increases, work done by the system or work done on the system will be takes place, means as W is positive means work done on the system will be taking place. సిస్టమ్ పైన వర్క్ జరుగుతుంది అంటే సిస్టమ్ ఎనర్జీని గెయిన్ చేసుకుంటుంది కాబట్టి పాజిటివ్, రైట్? సో అదే ఇంటర్నల్ ఎనర్జీ డిక్రీజ్ అవుతుందంటే ఎవరు చేస్తున్నట్టు వర్క్, సిస్టమ్ చేస్తున్నట్టు. సిస్టమ్ వర్క్ చేస్తే దాని యొక్క ఎనర్జీ అనేది డిక్రీజ్ అయిపోతుంది, మీన్స్ సమ్ ఎనర్జీ ఈజ్ డిక్రీజెస్. వెన్ ఎనర్జీ ఈజ్ లాస్ట్ దెర్ ఫోర్ ద ఆబ్టైన్డ్ వర్క్ ఈజ్ నెగటివ్, రైట్? ఇంటర్నల్ ఎనర్జీ డిక్రీజ్ అయింది, సో కాబట్టి ఈ టైంలో ఎక్స్పాన్షన్ ప్రాసెస్లో వర్క్ ఏమవుతుంది, నెగటివ్, రైట్? సో దిస్ ఈజ్ అబౌట్ అడియాబేటిక్ ప్రాసెస్, రైట్? Then coming to the part of cyclic process, right? So one last process will be there, that is a cyclic process, right? This is very important class, because whatever the process we are going to apply in further classes means we aware about all these points, right? Right. So put heading cyclic process. Right. Cyclic process. We already discussed that cyclic process means any process is carried out in a cyclic manner. System A is converted to system B, system B is converted to system C, then system C is converted to again system A. Here initial states are equals to final states. This is the one condition, that is a cyclic process, right? And second condition, the change of internal energy, change of enthalpy, change of Gibbs free energy, change of entropy, change of Helmholtz energy function, this all will be equals 0. But so what we are getting in the examination means such this terminology we will get, right? Integral, particularly which integral? Closed integral. Closed indicates cyclic process. Integral means that is the from initial state to final state, the entire parameter will be measured, right? Closed integral of dE is equals to closed integral of dH is equals to closed integral of dG is equals to closed integral of ds is equals to closed integral of dA. This all will be equals 0. This closed integral indicates cyclic process. This we have to remember. Right, so definitely we'll get which of the following is a cyclic process, that will be expressed in terms of closed integral. So generally one statement is what? Initial states are equals to final states. The other will be all the change of thermodynamic properties becomes 0. Then so that will be indicated with closed integral, that is integral dE, integral dH, integral dG, ds, dA is equals to 0. This is about thermodynamic processes. As you understand the process, which process is involved, what condition we have to apply, that you have to remember, right? Simple process చెప్పంగానే కాన్స్టెంట్ టర్మ్ ఏంటి, సో ఏ లాస్ అప్లికేబుల్ అవుతున్నాయి, తర్వాత చేంజ్ ఆఫ్ దట్ ప్రాపర్టీ ఏమవుతుంది, ఈ మూడు కండిషన్స్ని కంపల్సరీ గుర్తుపెట్టుకోవాలి. తర్వాత ఇంకొకటి ఏంటి, ఎనర్జీ అనేది ఎక్స్పాన్షన్ కానీ కంప్రెషన్ కానీ జరిగితే ఎక్కడి నుంచి యూటిలైజ్ చేసుకుంటుంది, ఇంటర్నల్ ఎనర్జీని వాడుతుందా, సరౌండింగ్స్ ఎనర్జీని వాడుతుందా, రైట్? సో దట్ 4 points you have to keep it in mind, because the further topics will be related to all this only. So before going to that, we have to discuss about one concept is there, that is reversible and irreversible process, right? What is meant by reversible and irreversible process? Right, this is very important, right? Reversible irreversible process. Right, simply I can understand easily, right? Right. What is meant by reversible, what is meant by irreversible? Reversible ante both direction reaction will be taking place, right? So reversible, first we have to discuss about reversible. Reversible means reactants are converted to products, then again products are converted to reactants. both the directions are taking place. మరి దాన్ని రివర్సిబుల్ కాకుండా ఈక్విలిబ్రియం అంటాం కదా సార్. రియాక్టెంట్స్ టు ప్రొడక్ట్స్, ప్రొడక్ట్స్ టు రియాక్టెంట్స్ అంటే ఈక్విలిబ్రియం అంటాం కదా. ఎస్, ఈక్విలిబ్రియం ఓన్లీ. ఈక్విలిబ్రియం అండ్ రివర్సిబుల్, రైట్. సో ద టర్మినాలజీ రివర్సిబుల్, హౌ వీ హ్యావ్ టు యూజ్ ఇట్ ఇన్ థర్మోడైనమిక్స్. సో in addition to that equilibrium, that we will discuss, right. Okay, coming to the part of consider a cylinder, right. Consider a cylinder with weightless frictionless piston, right. So this is the weightless frictionless piston. This weightless frictionless piston will be consisting gas. Cylinder consisting gas with considering weightless frictionless piston, right. పిస్టన్ అంటే ఒక తెర అనుకోండి, రైట్. సో మీన్స్ దట్ డజంట్ హ్యావ్ ఎనీ వెయిట్, డజంట్ హ్యావ్ ఎనీ ఫ్రిక్షన్. We said that boundary surface, that boundary surface will be imaginary boundary surface, or so that may be movable boundary surface, right. That we have to consider, right. So here inside pressure will be pressure of the gas, this is Pg. Outside pressure will be external pressure, right. Right, outside pressure will be external pressure, right. So which one is the driving force, which one is opposing force? Driving force, opposing force. Driving అంటే గ్యాస్కి సంబంధించింది ఏంటి, డ్రైవింగ్, రైట్. మనం కార్లో కూర్చొని డ్రైవ్ చేస్తూ పోతుంటాం, రైట్. సో గాలి అనేది ఆపోజిట్ నుంచి వస్తుంటుంది, ఆపోజిట్ డ్రైవ్ చేస్తున్నాం కాబట్టి మనం ఇచ్చే ఫోర్స్ ఏంటి, డ్రైవింగ్ ఫోర్స్, రైట్. సో దట్ ఈస్ డ్రైవింగ్ ఫోర్స్. దెన్ ఆపోజిట్ outside air will be opposite to us, right. That is opposing force, right. So like similarly, this is the pressure of the gas, in this direction force will be there, right. This is pressure of external will be down direction, right. So this is considered as opposing force, opposing force. This is the what, driving force. Opposing force and driving force. One condition you may consider, driving force is equals to opposing force. What will happen? The piston will be kept at this constant position because both the forces are same. When both the forces are same means that piston will be constant at that particular position only. If inside driving force will be more, the piston will move up. Opposing side force will be more, the piston will come down. So like that, if the pressure will be varying, based on that the piston will be moved, right. What I am going to do here means, right, I may put some sand particles, right. So these are the what, sand particles, right. Sand particles on piston means which side pressure is increasing, opposing force is increasing or driving force is increasing? As opposing force is increasing. When opposing force is more, with the help of addition of small sand particles on the piston, opposing force will be more, right. When opposing force is more, the piston will move down, right. The piston will move down, right. So this is the piston moving down. Whenever the piston is moving down means compression will be taking place, inside gas particles are there, those gas particles accommodate their pressures, and so that pressure will be matches with the external pressure, therefore hence the piston will be at that particular position, right. Here in this part, right, whatever the first piston place will be there, that piston will be moving down means, so because of external pressure is increasing with the help of sand particles. Some more sand particles you may add, right. So that will be here, the piston will be here. Like some more we have to add, right. The piston will move like here, right. So this is the second stage and this is the third stage. Total how many? So some many number of stages are there, right. Here I am indicating only 3, but many number of stages are there, that is also we may indicating like this, right. So this is the what, piston initial volume of the gas is V1, this is the final volume is V2. Initial volume is V1, final volume is V2. Is that piston moving directly to the final volume? No, there are many number of stages are there, right. So therefore these are the many number of stages will be there. At each stage, right, at each stage the difference between driving force and opposing force is very small. Hence that process becomes what? Reversible process. What we are going to say, the reversible process means, reversible process will be carried out in many number of steps. ఏ స్టెప్ దగ్గరైనా తీసుకోండి, అపోజింగ్ ఫోర్స్ డ్రైవింగ్ ఫోర్స్ రెండింటి మధ్య డిఫరెన్స్ చాలా తక్కువ ఉంటుంది. అప్పుడే పిస్టన్ అనేది అక్కడ హోల్డ్ చేయగలుగుతాం. రైట్. ఒకవేళ అపోజింగ్ ఫోర్స్ చాలా ఎక్కువ ఉంది, రైట్, సింపుల్ థింగ్, మీరు రాసే నోట్బుక్ని పైన పెట్టేసుకోండి, ఎంత కొంత ప్రెజర్గా ఫీల్ అవుతారు. రైట్. అదే ఒక 50 kgల బస్తా పెట్టుకోండి పైన, ఇంకా ఎక్కువ ప్రెజర్గా ఫీల్ అవుతారు. ఒక 2 క్వింటాల్స్ పెట్టుకోండి, ఏమవుతుంది? ఇమీడియట్ పడిపోతారు. రైట్. కింద అది హ్యాండిల్ చేయలేక ఏమవుతుంది? పడిపోతారు. అంటే ప్రెజర్ అనేది మనం ఎలా ఇస్తున్నాం అవుట్ సైడ్ నుంచి, స్మాల్ పోర్షన్స్లలో ఇస్తుంటే సో వేరియస్ స్టేజెస్ విల్ బి దేర్. అదే ఒకేసారి లార్జ్ పోర్షన్లో ఇచ్చేసినాం, ఇన్స్టెడ్ ఆఫ్ దట్ శాండ్ పార్టికల్ పుట్ వన్ బిగ్ రాక్ ఆన్ ద పిస్టన్, ఇమీడియట్లీ పిస్టన్ విల్ కమ్ డౌన్. దట్ ఈస్ ద ఓన్లీ వన్ డైరెక్షన్ ప్రాసెస్. The difference of driving force and opposing force is very large difference is there. So hence that is the process is called irreversible process. Whenever so the various number of stages are there, so at each stage the difference between driving force and opposing force is very small. So such process is becomes what? Reversible process. Such process becomes reversible process. Instead of sand particles, if you may use rock, right, so piston will move directly to the final stage only. Right. So that is the process is known as irreversible process. Right. In irreversible process, right, we are getting only two only. Right. So what is meant by irreversible process, that we will see. Right. So instead of sand particles we are using rocks. Right. So that is the same systems we are going to consider. Right. So this is the gas will be there, pressure of the gas is this is in this direction, up direction, external pressure will be down direction. Right. So whenever we may put some rock, right, this is the what? Rock, big rock. Right. So immediately the piston will move down. How many stages are present here? Only 2 stages are there, that is V1 and V2. Right. Except these V1 and V2 positions, where the volume at V1 at the time only driving force and opposing force will be same, therefore the piston will constant at that place. Right. Once we may put the rock, immediately it will come down. There how the piston will be take place means, there also driving force and opposing force difference is small. Means initial and final state the process becomes reversible. In between all the entire process becomes what? Irreversible. Because here the condition is what we have to get that condition means V1 to V2 directly it will come. No stages are there. Right. So because of high external pressure, what was the reason means, external pressure will be very very high compared to pressure of the gas. With the help of this condition the piston will come down directly. Hence what we are going to say, right, so the difference between driving force and opposing force, the difference between driving force and opposing force is large. Hence that process becomes what? Irreversible process. All the irreversible processes becomes what? Spontaneous processes. All the irreversible process becomes spontaneous process. Right. This is the difference between reversible and irreversible. Right. So this is the difference between reversible and irreversible. Right. Just see the differences, both the differences, right? So this is the process is what? Reversible process. This is the process is what? Irreversible process. For irreversible process, only one direction, reactants or give stress to product only. Only one direction is possible. Here both the direction, two directions are possible, right? Only one direction, just you have to observe the diagrams, from that you will get the idea clear cut, right? Here many stages are there, that becomes what? Reversible. At any stage, the difference between the driving force and opposing force is small. That process is becomes what? Reversible process. See here, only one. So one is the white and other one is the yellow, means only two stages will be there. So directly it will come down and stay there only, right? Hence the pressure of external will be very high compared to pressure of the gas. Hence the difference between the driving force and opposing force is very large. So such process is becomes irreversible process, right? This is the concept of about reversible, irreversible, right? Reversible, irreversible, and expansion, compression, how we are getting that process, that we have to know. This all we have to combine together. We will get isothermal reversible expansion process, isothermal reversible compression process, adiabatic expansion process, adiabatic compression process. For all we have to calculate the work done, that will be mentioned in the syllabus. That is the important thing, right? So as we have to understand, that means we will get as we want to get that all those topics, means we have to understand this entire topic in detail, right? Okay, so in addition to this, one small concept is there, so that also will be discussed. That is the concept is known as what? Heat capacity, right? This is about reversible and irreversible process. The extension of this will be discussed in further class, right? Before that, the small concept is there that we are going to discuss, that is the heat capacity. Heat capacity, right? What is meant by heat capacity? That will be denoted with C. Heat capacity will be denoted with C. Everyone has some capacity, means what is your strength? Strength is nothing but we may consider as capacity, and what is your strength, what is your weakness, and all those things we have to consider, right? So then here also heat capacity, what is meant by heat capacity means, see, very simple, just we have to understand with the help of simple picture, right? There is a system is there. The system is at temperature is 25 degrees centigrade. System is present at what temperature? 25 degrees centigrade, right? Now I want to rise the temperature of the system to 26 degrees centigrade. I want to rise the temperature. How much temperature will be increasing? 1 degree centigrade. 25 to how much? 26. Means this is 1 degree centigrade. I want to rise 1 degree centigrade of, this is the what? Any system. Some amount of energy is required. Some amount of Q means heat is required. This heat will be considered as heat capacity. This is the thing, right? How it will be very simple. Just we will go with statements. How we'll get the definition of heat capacity and how we'll get the equations. All those things we'll see, right? System is there. Temperature is present at 25 degrees centigrade. I want to rise up to 26, means 1 degree centigrade. How much amount of heat is required? The statement will be the amount of heat is required, right? So what about the heat capacity means? The amount of heat is required. The amount of heat is required to rise the temperature, by to rise the temperature of any substance, any substance by 1 degree centigrade is called heat capacity. So this is the statement which will be applicable for all whatever we are going to discuss. Okay, right. Heat capacity is extensive property or intensive property? Heat capacity, it is a extensive property. Depends on weight or depends on number of moles. Depends on weight or depends on number of moles. Therefore hence it is a extensive property. Right. How much amount of heat is? It is a path function or state function? Heat is path function only. All will be correlated like this, right? Okay. The amount of heat is required to rise the temperature of any substance by 1 degree centigrade is known as heat capacity. What are the equations of that heat capacity? We'll see, right? System is at 25 degree centigrade to 26 degree centigrade. So therefore, how much C is equals to how much heat is required, right? How much heat is required to rise this 1 degree centigrade, right? For 25 to 26. For 25 to 26, what is this? Heat capacity is how much? 1 degree centigrade. So means to 1 degree centigrade C is equals to Q only. C is equals to Q, right? So then how much amount of heat is required to rise the 1 degree centigrade, right? So then, right, if temperature is T1, temperature is T2, right? T1 to T2. So what is the heat capacity is required? That means that is Q by change in temperature, right? So means we don't know the temperature differences, right? Therefore we have to consider these temperature differences here. So that divided with Q, so that will be equals to heat capacity. Hence C is equals to what? Q by delta T. Q by delta T. For 1 degree centigrade, here what is the 1 degree centigrade? Directly 1 degree we have to take. If we don't know whatever the temperatures are there, that temperature difference, but this temperature difference is applicable for what? 1 degree only, right? Temperature difference is applicable for 1 degree only, right? So if 5 degree, 2 degree, 3 degree will be there, right? So how much amount of heat capacity is required? So like that for n degree centigrade changes, right? So therefore this C is equals to Q by n into delta T. N degrees means that we have to write like this. For 1 degree C, right? For n degrees means this n will come here, means n into C. N into C. That n into C will be written in the form of like this. C is equals to Q by n into delta T. This is the equation and definition and diagram for heat capacity, right? This is the concept of heat capacity. Simple, go with diagram. System is there. The system is going to absorb some amount of heat energy to rise 1 degree centigrade. That is known as heat capacity. Heat capacity is always considered for 1 degree centigrade only. If temperature will be changes, right? 2 degrees, 3 degrees, 5 degrees will be changes like that. Therefore we have to utilize this formula, that is Q C is equals to Q by n into delta T, or for 1 degree centigrade that is C is equals to Q by delta T, or else 1 degree directly 25 to 26, that is C is equals to Q. How much amount of heat is required to rise the temperature from 25 to 26, that is known as heat capacity C, right? So therefore here we will get some terminology which will be related to this specific heat capacity and molar heat capacity, right? So that both we will discuss, right? Based on this only, so definitely we will get so all those things with simple manner. Specific heat capacity, specific heat capacity, that is denoted with S. That is denoted with S. So similar to that, right, here what we are taking? 1 gram of substance we are taking. Specific amount we have to consider, that will give specific heat capacity. Previously what we consider? Any system we consider, any system, we don't know, that is either in grams or moles or whatever it, right? But here particularly 1 gram of substance, right? So this 1 gram of substance temperature is 25 degrees centigrade is there. I want to rise 1 degree centigrade, 1 degree centigrade. How much amount of Q is required? That is known as specific heat capacity. Simple thing, the amount of heat is required to rise the temperature of 1 gram of substance by 1 degree centigrade. 1 gram of substance by 1 degree centigrade is known as specific heat capacity, right? So C is equals to, we know that Q by delta T, or we may written as Q by T also, right? So where T is equals to 1 degree centigrade, or delta T also 1 degree centigrade. The corresponding Q will be equals to heat capacity, right? But here m 1 gram of substance is there. For m gram of substance, this is the heat capacity. Then specific heat capacity will be S, that will be denoted with S, right? So specific heat capacity will be denoted with S, that is also Q by delta T, that is Q by T. But here 1 gram of substance, this is applicable for what? This is applicable for 1 gram of substance. For m gram of substance, S is equals to Q by m into delta T, that is applicable for m gram of substance, right? For m gram of substance, by rearranging of this equation, what we will get? Q is equals to m into S into delta T, m into S into delta T, right? So this is the heat and this relation, right? When Q is equals to S means m will be considered as 1 gram, delta T will be considered as 1 degree centigrade, right? Delta T will be considered as how much? 1 degree centigrade. The mass will be considered as 1 gram. These both are 1 means S will be equals to Q, that is the specific heat capacity, right? So this equation we have to remember. Coming to the part of molar heat capacity, instead of 1 gram, right, simply, so I may consider 1 mole of substance, 1 mole of substance, right? Same thing, Q, then temperature will be rises to 1 degree centigrade. That is known as what? Molar heat capacity. Molar heat capacity. Molar heat capacity, that is also denoted with C. If molar heat, that means Cm, right? So same thing, 1 mole of substance is there, right? So therefore C is equals to Q by delta T. So this is the heat capacity. For m moles, Cm is m is 1 mole, that is Cm. So therefore Q by delta T only. This is applicable for 1 mole. 1 mole only we have to consider, right? If many number of moles are there, 2 moles, 3 moles, 5 moles, like 10 moles, some etc. is there. So that we may consider that equation Cm is equals to Q by N into delta T, right? So this is applicable for m mole of substance, right? This is n mole of substance. N mole of substance. So from this what we are going to write the equation? Q is equals to Cm into N into delta T. This is applicable for N moles, right? Similar to here, what is the N? If it is applicable for 1 mole, the delta T will be 1 degree centigrade. Therefore the corresponding C will be equals to Q, right? See, molar heat capacity, specific heat capacity and heat capacity, right? So this molar heat capacity at constant pressure and at constant volume, we can get other two terminologies, that are Cp and Cv, right? So we will get the Cp Cv. We know already relations, Cp and Cv relation is what? Cp minus Cv is equals to R. Cp minus Cv is equals to R, right? So therefore this is the specific heat capacity, molar heat capacity and heat capacity concept, right? So somehow continuation topic will be there. So that is what is meant by molar heat capacity at constant volume, what is meant by molar heat capacity at constant pressure, what is the relation between them, So what are the applications of that Cp and Cv values that will be applicable for what kind of applications are there, and what is the work done for isothermal and adiabatic, all those things including zero and first law. So that we will continue in the next class. Right? Thank you.